You got it. I think you got the product rule down. Let's try the quotient rule. Shall I give you one?
Yeah.
Okay. If I got y equals, instead of a and b, I'm going to use what most of the books use, which are u and v. Is that what your class uses?
Yeah.
Okay. Now, there's an excellent way of memorizing the quotient rule. You don't have to memorize much. Starts with the bottom, ends with the bottom squared. That's all you have to know. So, by that, I'm going to start with v, not v prime. So the next thing has to be u prime. And order matters in the quotient rule. I cannot do it in either order, and that means subtraction must be taking place. And what's being subtracted is the opposite of this. So I'm going to subtract v prime times u. And remember, you end with the bottom squared. So that's, to me, that is absolutely the easiest way to memorize this thing. Start with the bottom, end with the bottom squared. Everything else you will be able to figure out. In other words, if you're starting with the bottom, well, you know it's multiplied by the top, must be the derivative of the top. Subtraction, do the reverse, v prime times u, and then end by v squared. Okay? All right, let's try one. Let's do x divided by sine x. So what's y prime equal to?
So, cosine x.
Start with the bottom, not the derivative of the bottom. Start with the bottom.
So sine x minus cosine x times x.
Generally good to put the x in front there, because if I put it back here, it makes it hard to understand what's going on. Divided by what?
Over sine x squared.
Sine squared of x, which is a little different. These two are not the same thing. This one means sine x times sine x. This one means you square the x first and then you take the sine of it. So they're a lot different. Okay? So it's definitely sine squared of x, because the bottom squared is sine x times sine x, which turns into that. Okay, you have some?
Yeah.
Let's do enough of them so that I know you know how to do it.
How about cosine x over x cubed plus 1?
Okay.
So, x cubed plus 1
In parentheses.
times negative sine of x.
Got to be careful how you write that, because it's really easy to interpret that as minus sine x instead of being multiplied by minus sine x.
Oh yeah.
Okay.
Minus 3x squared times cosine of x over x cubed plus 1 squared.
And you can leave it like that. You don't need to actually square that.
Okay.
Okay? All right. I don't want to ignore the chain rule, because that is probably the hardest thing to understand.
Yeah.
We'll go back and do another quotient if we have time, but let's get on to the chain rule.
Okay.
Let me give you one. Now, the quick and dirty method of the chain rule is the derivative of the outside times the derivative of the inside, right?
Mm-hmm.
That's what they teach you. I mean, I can get into it deeper, but that generally suffices. If you think of the derivative of the outside times the derivative of the inside, you can avoid using U substitution. So what's the derivative of the outside?
Cosine.
Of the same argument. Don't change the argument. Okay? Now what's the derivative of the inside?
2x.
I'm going to put that in front again, just because it looks, if I put it there, it's confusing.
Yeah.
So I put it in front because you're not taking the cosine of that 2x. You're multiplying 2x times the cosine of that. But you see how we get the derivative of the outside times the derivative of the inside.
Yeah.
I'll give you one more. What's the first thing you want to do here? Radical signs don't work very well when you're taking derivatives. On the other hand, fractional exponents work really well. So always get rid of your radical signs so that you can apply the power rule.
Okay.
Oh, how do I get rid of the radical sign?
So in parentheses it would be x cubed plus 1 to the 1/2.
Okay. Now let's find y prime. What's the derivative of the outside?
3x.
No, start. That's the inside. In other words, pretend that this is u to the 1/2, where u is x cubed plus 1. So if you took the derivative of the outside, it would be 1/2 u to the minus 1/2, right?
Mm-hmm.
So that's the derivative of the outside. So what is that?
1/2 times x to the third plus 1 to the minus 1/2.
Okay, now what's the derivative of the inside?
3x squared.
That's the chain rule in a nutshell. Let's do more chain rules. Do you have another one? Or do you have some?
About 3 times 4 minus 9x to the 4th.
Hold on, I don't think I heard all of that. Y equals what?
3 times 4 minus 9x to the 4th.
Like this? Parentheses?
Mm-hmm.
Okay. It's the derivative of the outside. First of all, I suppose the most important thing to do on these problems is to tell yourself or ask yourself, what is the inside? And just for practice, we're going to call the inside u. So what is u here?
4 minus 9x.
Okay. Which means what we're really looking at is 3u to the 4th power, right?
Mm-hmm.
So what's the derivative of that?
12.
U to the 3rd.
Yeah.
But that's just the derivative of the outside. Now take the derivative of u, which we have to multiply it by. What's that?
9.
Minus 9. Then we have to go back and substitute. In other words, we do not want to give our answer in terms of u. We want to, u was 4 minus 9x, so it's 4 minus 9x to the 3rd, all times minus 9. So this, and then of course you'd want to multiply the minus 9 times the 12, so you get minus 108 times 4 minus 9x to the 3rd. Now, you don't have to necessarily use this U substitution. Have you been introduced to U substitution yet at all?
No, not really.
No? They didn't even talk about it when they talked about the chain rule?
No.
Okay, that's fine. We don't need to use that. You're going to use U substitution at some point in calculus very soon. But for now, you can just look at it as doing the derivative of the outside times the derivative of the inside. So if I don't use U substitution here, then the second step, the derivative of the outside is 4 times 3 times the original inside to the third power. So that's the derivative of the outside. And then times minus 9, the derivative of the inside. But you definitely have to recognize what is the inside. It's not always perfectly clear. For example, what's this? First of all, do you know what the derivative of e to the x is?
It would be x.
E to the x. No. When the exponent is in, or when the variable is in the exponent, you cannot use the power rule.
Oh.
That's out, okay? So if I have y equals e to the x, the derivative is not x times e to the x minus 1. The derivative is e to the x. It's the only function in the universe whose derivative is the same as the function.
Okay.
Okay, so very important function. That's why e to the x is so important, is because its derivative is the same as it. So the derivative of the outside is what?
Is e to the x, or e to the 3 times x?
Yeah, never change it. If you're, in other words, if the derivative of e to the x is e to the x, then the derivative of e to the 3x, the outside, is e to the 3x. But now I got to multiply that by the derivative of the inside. Well, what is the inside?
I don't know.
3x. In other words, inside is always, if I use this u substitution and I let u be 3x, then really what I'm looking at is y equals e to the u. And I know how to take the derivative of e to the u. Y prime is e to the u times u prime. In other words, the derivative of the outside times the derivative of the inside. Only thing is you have to know what the inside is. And that's not always that easy. But usually it is. Once you get the hang of it, you'll know what the inside is. So yeah. I'm multiplying that by 3. Okay. All right. What do you got? Chain rule problems. Let me just say one thing before I forget. Second derivative is super easy. Second derivative is the first derivative of the first derivative. Okay? No, seriously. So if I had x to the 4th as my function, then y prime is 4x to the 3rd. What's y double prime?
Is 12x to the 2nd.
That's second derivative in a nutshell. In other words, you don't need to take second derivatives. Second derivatives are always first derivatives of first derivatives. So if you have a function and they want to know the second derivative, you've got to go through that step. You've got to calculate the first derivative first, then the first derivative of that.
Okay.
Now let's get back to chain rule, because this is where most of the students have difficulties with.
How about y equals 1 over root x plus 2?
Okay. Let's write that with Fractional exponent instead of a radical sign.
So 1 over x plus 2 to the 1/2.
Now let's write that with everything in the numerator so I can use the power rule.
Is it 1 times?
No? Well, yeah, but I don't need the 1 anymore.
Okay, to the negative 1/2.
That's what negative 1/2 means, is that it would be in the reciprocal. Okay? Now I can use the power rule and the chain rule. So what's the derivative of the outside? Starting with that.
Negative 1/2 times x plus 2 to the negative 3/2.
Okay? Times the derivative of the inside. What's the derivative of the inside?
X. I mean 0.
1.
Oh.
Remember, the derivative of constants is 0, but the derivative of x is whatever the coefficient is, which is a 1. So I'm going to multiply it all by 1. Don't need to even write it. Okay. If that was 3, let's say, now the derivative of the inside is 3, so I would have to multiply the whole thing by 3. Okay? What else you got?
X times the cubed root of 1 minus x squared.
Okay, what's the first thing I want to do?
Figure out what the inside is.
Get rid of the radical.
Oh, right.
You cannot use a radical when you're using power rule, product rule, quotient rule. None of them work with radicals. You got to change the radical to a fractional exponent.
Okay. So 1 minus x squared to the 1/3.
Okay. Now, that's why. Now we're going to have to use a combination of product rule and chain rule. I'm glad you got this one because this is going to teach you a lot, this specific problem. So let's start with product rule.
Okay.
Remember, you always start by taking the derivative of the first term.
So 1 times 1 minus x squared to the 1/3.
Okay. Don't need to apply the chain rule yet because I didn't take the derivative of that second term yet.
Right.
Okay. Plus what?
Plus x times 1/3 times 1 minus x squared to the negative 2/3.
Now we have to apply the chain rule because we were taking the derivative of that term. So is all you really did by doing that was take the derivative of the outside.
Oh.
Now multiply it by the derivative of the inside. Well, this is clearly the inside.
Yes.
What's the derivative of that?
Negative 2x.
Yeah. Don't need this one here. And I can write this a little nicer. Let's simplify this a little bit. In other words, a lot of derivative calculus is hard algebra. Okay? In other words, you need to be able to simplify this. Well, I'm going to start by putting the 1/3 and the -2 in front. Here's my 1/3 times the -2. And then I got x times x, so that becomes x squared. Then I still got my 1 minus x squared to the -2/3. So that's a sufficient answer, unless your teacher says don't ever give answers with negative exponents, and then you'd want to put that in the denominator to the +2/3.
Okay.
Okay, but there's no more simplification to be done. There's some factoring. You're going to find with the quotient rule sometimes that the algebra gets really, really tough and involves a lot of factoring and canceling, and that's the biggest problem. It's not the calculus, it's the algebra. Notice one thing I could do here is factor out a 1 minus x squared to the -2/3 power. I can do that. In other words, you can there is a greatest common factor here. You're not used to doing it when you see negative exponents, but it can still be done. We won't get into that just because that's a lengthier subject, but it is something that could be done. And yeah, this problem has it all. In other words, this problem has product rule and chain rule and radical signs. So if you can do this problem, you know how to pretty much do them all.
Good.
Well, there are some quotient problems that can get extremely tough. Let's just do one more before I let you go.
Okay.
It's y prime. What's the rule? Tell me the rule verbally.
The bottom times the derivative of the...
Start with the bottom and end with...
the bottom squared.
Okay, that's all you need to know how to do it. Tell me what to write.
X minus 1.
Starting with the bottom, okay.
Minus.
Remember, it's got to be times the derivative of the top.
So times 1.
And order matters, so it's got to be subtraction, otherwise order wouldn't matter. Now do the reverse.
1 times x plus 1.
Okay. All over
X minus 1 squared.
Okay. Now, notice that I can simplify the top quite a bit. I don't need that one, don't need that one. When I remove the parentheses, I've got x minus 1 minus x, and that plus 1 turns into a minus because you got to distribute the minus to it. So now I've got that after removing all the parentheses. Now notice the x's go away and I'm left with -2 in the top. So I got -2 over x minus 1 squared. So there's an example where you can take something that's fairly complicated and simplify it into -2.
That's nice.
Yeah, but that's kind of what I'm saying, is that when you use the quotient rule, you almost always have some rather complicated algebra to apply to simplify. It's rare that your final answer is what you have written in that step there. In other words, I was able to simplify that numerator substantially.
Yeah.
And had I ended up with something like x minus 1 in the numerator, then I could have canceled it. In other words, I could have simplified it further by taking off one of the x minus 1s in the denominator. And that happens frequently also. But especially when you're applying the quotient rule, the algebra can get, it's definitely college algebra.
Yeah.
But doable, just hard and complicated.
Yeah.
Okay. Will that do it tonight for you, Brianna? I noticed it looked like you might be trying to sign up for 2 half-hour sessions. If you have a need, I'm happy to go more tonight.
Oh no, I don't think so. It might be my sister.
Oh, maybe that was her. I happened to be looking at my calendar and I saw at the same time somebody was trying to sign up for 7:30 to 8 and then 8:30 to 9. And I figured that was maybe you looking for an hour appointment. So that's why I asked.
Yeah.
So you good to go for tonight?
Yeah.
Okay. This will be posted by tomorrow morning if you want to review it.
Uh,
Okay, Brianna. Have a good evening.
you too. Thank you.
Bye-bye.